Hey there!
Hey.
Section 3, Polynomials of Higher Degree and Modeling. This is where the fun begins.
Yes, because before now we've been talking about, in the first section, polynomials of first and second degree, linear, quadratic. Then we talked about power functions, and that got kind of crazy. Now we're back to polynomials, but higher than second degree, so third, fourth, fifth, sixth, and all that. We have some names for those functions.
We do have some names for those, and sometimes you can use those names, but then it just gets to a point where you refer to it by degree.
Yes. So like the third degree is
cubic.
The fourth degree is
quartic.
And the fifth degree,
quintic.
Sixth degree? Let's
degree
not go there.
6.
Yeah.
I just call it, if you've got a 6th degree polynomial that we're graphing, it's a 6th degree polynomial instead of hexagononial or whatever. What would it be?
I don't want to say.
Okay.
Okay.
Fair enough.
Okay, it's a secret. Anyway, so polynomials written of degree n can be written in the form right here. Okay, where basically these a's are just our coefficients. And then if you look, we have this n here, and then we have n minus 1, and then it gives us a little section that says, you know, other stuff happens until it counts down to a squared of first power, and then this would be like x to the 0 power. Not 6, 0. And so what's happening with this notation is, like, if this is an nth degree polynomial, like if it was actually the 6th degree, well, there'd be a 6 here where this n is.
Followed by
a 5 and a 4 and a 3. And they might skip
6
some.
minus 1, 6 minus 2.
Right, that's what that notation is saying. And that the math notation in here can be tricky, and you really don't need to usually understand it until you get into really high-level math, and all of a sudden you're having to like see that stuff all the time.
But look for the pattern on each problem, because that's the key.
The more you see it now, the easier it'll be to understand whenever it's actually important.
Right.
We'll tell you what all of this means. So some definitions here. We have, we talked about monomials last section, that a monomial is one term polynomial. And so each of these monomials is a term. And so what you do is the leading coefficient and your x, that's a term. And the leading coefficient, remember, always gets whatever sign is in front of it. So if it was like negative 3x to the third, that whole thing is one term, including the negative.
So the terms are broken up by the plus and minus signs.
Right. So they're all broken up. And then there'd be terms in the middle here, broken. Okay? Standard form happens whenever we write it with the degree descending. Like your biggest degree should be first, followed by the next lowest, followed by the next lowest, and so on.
And if your problem isn't organized that way, for all of the things that we're going to do, you will want to rearrange it.
Yeah.
Making sure that you keep the sign in front of the coefficient with it wherever it travels to.
For example, like 5 minus x squared, hey, that's not in standard form. So when you rewrite that, make sure that negative goes with the x squared. 5 is positive, so rewriting it would look like that.
A good question to ask yourself is, what kind of x squared do we have?
We have a negative one.
We have a negative one, and it's got to stay with it the whole time.
Yes. The constants in front, all of those a's are the coefficients of the polynomial. And we call the first term, if it's in standard form, the leading term. And so it has a leading coefficient, which we talked about the other day.
If you're leading a race, you're in first place.
Yes.
And
I don't know what that feels like personally, but some people would know what that feels like.
I know what that feels like.
In a race.
Yeah, I was first once.
I've been first on a roller coaster, so that's
a leading roller coaster form.
It's similar. Okay. And A naught is a constant term. It's just a number there at the end. You always end with, if there is just a number by itself without an x, that's always the thing that goes last.
Yep.